There we go. And hello. So my name's Linda Detweiler. I was a chemistry teacher for 10 years, and now I am the head of customer success for Pivot Interactives. And today I want to talk about all the things that Pivot can do that people don't know Pivot can do. And so I'm just going to come onto the website, and just in case we don't know what Pivot is an online science education platform that focuses on phenomenon-based active learning. And we have all these activities, and I think everybody knows about the general Pivot activities. If you come over to the library, you go to subject, chemistry, boom, you have all these activities. Everybody knows about these. And we have activities that are really neat. Like take, for instance, this glow stick one. Super simple activity. We're just looking at what factors impact reaction rates with glow sticks, right? And this is, I think, the part that everybody knows Pivot can do. And it's funny because I was on a Facebook group recently and somebody was like, I thought Pivot was just a bunch of videos, because this is what people know Pivot to be. You have basic tools. I'm going to add, my internet's being really slow right now. I think it's because I unplugged my computer a little bit ago and plugged it all back in. And now it's like, how dare you? You moved me across the house. Horrible. But basic, I'm going to speed this thing up, just move it forward. Okay, we're going to add a glow liquid and then time how long it takes for the reaction to stop. This is the part of Pivot that everybody knows and is really used to. But there's way more to Pivot than just this. Don't get me wrong, this is great. Collecting information with a timer and filming these, like, that's all super cool and wonderful. We can do better. So I want to kind of showcase 4 different activities that we can do inside of Pivot right now. And the first one that I want to talk about, one that I think is a time saver that we just kind of take for granted, is we have a lot of auto-graded activities inside of Pivot. We use PhET simulations for some of our activities. So I'm going to come over here and I'm going to search builder. And we have this atom builder. This is the same activity that we've probably all used. It's with PhET. We are officially partnered with PhET Interactives. We also have something called the PhET.io. And PhET.io actually allows us to specifically design these simulations for our platform. So we can say things like, when I launch this, I could say, I'm automatically going to come into the atom game and I'm automatically going to have 2 protons, 1 neutron, and 1 electron. And all the students will see is this. They don't see any of this other information. That's stuff that we can do in PhET.io, and we have more of those activities coming out. But what I love about this activity in particular is that all these questions that we see with the activity, every single one of these auto grades. So when I think about the atom builder activity that I do inside my classroom, it is a worksheet. I got it off of PhET. I actually was one of the people who modified it. So if you go onto PhET Interactives and you look for the build an atom activity, I was one of the modifiers on that activity. So I've got a version of it. I have a complete answer key for it. And it's like 4 pages. And I would grade that thing manually. And it is obnoxious to grade manually. This activity, every single part of this automatically grades. So beginning with 1 proton, 1 neutron, 1 electron, build your first atom. So I just launched my simulation. And my internet's being really slow for whatever reason. There we go. 1 proton, doop, 1 neutron, doop, 1 electron. Ta-da. And then I'm going to answer some questions. And I can actually put this so that this simulation shows up right here with it. So when I add this to my library, I have full edit access to these activities. So I'm actually going to be updating this one today so that you don't have to keep going up and down. The questions will just be right next to it. But all of these questions, it says, which particles are located in the nucleus? I'm just going to select proton. That's an incomplete answer. Therefore, it is wrong. My students are going to automatically get the feedback that yes, the protons are located, but hey, this isn't correct. And they already have a hint that says select all that apply. So we can try again and automatically get it correct. And as an instructor, I can change everything that's here. So for example, I could give them more submissions. I could give them less submissions. I could make this hint say that there are 2 correct answers. I could change anything that you see inside of the feedback. All of this is editable. So then it says, next you'll explore which particles are responsible for the identity of the element. Experiment by adding and removing protons. Observe if the identity, the name of the element changes. Repeat for neutrons and electrons. So I come up here and this keeps resetting right now because I'm inside of a teacher account. But I'm going to put a proton, a neutron, an electron, and my students would add a proton, open change names. Well, let's see if neutrons do it. Nope. What about electrons? Nope. Also, a fun fact about the simulation. Notice that the electrons are slightly smaller than the protons and neutrons. Just a visual thing that a lot of people sometimes miss. So I would say that the protons change the identity. All of these are the exact same questions I've asked my students a million times. But then I come to these. A lot of the stuff with parts of the atom is numeric based. We have numeric auto grade questions. So this one says an atom's atomic number is the number of protons that identifies the element. The atomic number is shown as a whole number on the periodic table. What's carbon's atomic number? So I'm going to type in 12.01. Whoops, it looks like you've entered the atomic mass. This knows that I didn't enter in the correct answer. In fact, we've programmed this one to tell me that that number is the atomic mass. We can actually set up a whole bunch of different feedback points based on a bunch of different numbers. So if I had typed in boron is 5, whoops, tells me again, that's an incorrect answer. Now let's put in the correct answer for carbon as 6. I could set up as many feedback points as I wanted to here. And again, this is auto grading. And because this is a numeric auto grade question where it's not multiple choice, my students can't just guess to this answer. There are a whole bunch of different numbers here, and there is an infinite number of numbers that you could type into this. So my students can't just go down a list and eventually run out of numbers to guess. They have to actually interact with the information. So as I look at this activity, every single question here auto grades, which means as an instructor, I'm not going to grade this activity. When they get this score at the end, that is the score that goes to the grade book. That's one less thing for me to deal with that day. This activity, if I go up to the top, we'll see that this activity takes a full class period to complete. The same time my build an atom simulation has always taken me, plus or minus 45 minutes. So this is the same activity, but this one completely auto grades. It works with my classroom and it gives them feedback instantly. One of the downsides with auto grading is that a lot of times we tell them like that answer is not correct and that's it. We don't tell them why. Inside of Pivot, we can not only personalize the correct answer, we can personalize the feedback. And we have a whole bunch of these auto graded activities. As you look through an activity, just anything that's multiple choice, multiple select, and numeric is going to auto grade. So that's activity number 1. I feel like that's probably the one that you're the least surprised by. Any questions here so far? Go for it, Donna.
So the final grade that they get that's after they've had a chance to submit the correct answer.
Yes.
So, okay.
Yeah. So the way our activities work, and I think it's a really neat thing to point out, is we kind of take this game approach to learning. So if you think of a traditional grading system, in a traditional grading system, students lose points for getting incorrect information. When you grade a question, if it's worth 10 points, the student did these 3 things incorrect, then they would lose 3 points. Rather, inside a pivot, the way we work is everybody starts at a 0 and you can only gain points. So by correctly completing activities, this also kind of confuses students the first time they do it, because when they come to an activity, their score is a 0. And then they do this. They go to the first question, they get it correct, and their score is a 4. And they're like, but I got it right. I'm like, you're right, you did. You got 1 question out of 25 right. You have earned 1 point. You're going to build your way to a 100. You have to earn. I always told my students, grades are commission, not salary. You are not guaranteed an A in this class. You have to earn it by doing work. And so that kind of helped them in that process. But yes, that score is after they run out of submissions. Now, I have 1 submission here. I could leave this alone. If I use my other submission and I get it wrong, it will reduce my score. But notice I got it wrong and I'm out of submissions. I can't change that answer. So we often tell students, like, if you get it right, leave it alone. You don't need to go back and change it if it's right. And that's just that strategy for don't mess with things that are done right the first time. Good life skill for them to have. So that's activity number 1. And I really want to showcase this numeric auto grading because I think for me as an instructor, it's really helpful. So I'm going to go to one. This is a nuclear one, and it's under half-life. And so this is a nuclear activity. We're looking at the radioactive decay of a barium-137 sample. And it used to be that you could get these little sample discs. You could actually, back in like the 80s, they would send you these discs from the NRC. You could write to the NRC, the Nuclear Regulatory Commission, and they would send you a Geiger counter and the disc. And there are still some programs in the country that will send you radioactive discs. So they're completely harmless. The amount of radiation that's coming off of this disc is so minimal, like you get more from a banana, but it's there. And so you could still get these discs. The discs aren't hard to get. It's this right here. This is a digital Geiger counter. This is actually going to do our counts of all the radiation. That part's expensive. So when my students are like, why can't we do this in class? I'm like, that's radioactive. And they go, oh. And I'm like, but that's not actually the problem. The problem is that Geiger counter costs about 1/10 of my salary. So we can't buy a class set of 10 of them if you want me to also be in this room for the entire year. And I'm going to put this into split question view. And again, we have one of these numeric auto grade questions. What I love about having this question right here is our students are about to take a whole bunch of time data. In fact, they need to take 17 different measurements. If their stopwatch is messed up, all their measurements are going to be messed up. And I don't want them to get 17 minutes worth of data. And then at the end of it, it's like, just kidding, kiddo. Your data was wrong. So sorry. Go do it again. Because my high schoolers are just going to check out the moment they get to that point. So here we have a question beforehand that says, let's make sure your stopwatch is zeroed properly before you take all those measurements. And we give them instructions, zero the stopwatch when the data first appears. So I pull out a stopwatch. I'm going to play. Oh, I see data. Back. So I should be stopping my stopwatch right there. But let's zoom this thing to the end and let's pretend that I didn't. It says, once you've zeroed your stopwatch, fast forward to the end of the video. What's the total time of the video? Is 17.47. I'm immediately going to get feedback that says this isn't correct. And notice I have unlimited submissions here. I'm not going to limit them on the number of times that they can zero their stopwatch. Like, I want them to do this until they get it right, because that's so important for their data collection. So I'm going to actually go back and zero this properly. So boom, pull this thing forward. All right, 0. Zoom it to the end, 17 minutes. Submit. Now I get the feedback that I have zeroed my stopwatch correctly. Something else to note here, there are actually 3 different concentrations. It actually doesn't matter which concentration your students select. If I do this on a medium one, I'm going to see that that's where I start taking data right there. So I'm going to zero it again, zoom to the end of the video, 17.02. That one's also going to work. We've programmed in each of these correct answers. So whichever correct answer they select, it's still going to, whichever video they select, it's still going to mark them as correct. Now, I can come over here, get my data measurements, and just for the sake of time, I'm going to show the answers so that you can see, because that's a lot of data points to put in there. We actually tell the students to do a measurement at each minute, but when we made our answer key, we did 5 per minute. So there are 79 data points there. And here's your lovely graph that you get. Now our students are going to be asked some questions. And again, all of these are auto grading. So it says set your y-axis to total count versus time. So this needs to be total versus time. Hey, look at that. What graph does this match? And they can make a visual match. So we're teaching them that this is called an inverse exponential graph. Important thing for them to know. They're in algebra 2. Usually if we're covering nuclear at this level, we're talking about logarithms and exponential functions. And then another one, change your vertical axes. But now I want to get down into these calculations. So we're going to teach our students how to actually find the half-life. So we're going to make the half-life formula from the first order rate law formula. And it says, take a look at your graph. How long does it take for 50% of the barium to decay? So if I go up to my graph and I want this to be rate of decay, so I want 50%. I started with 1070. So I'm going to say that 50% over here at half of my time, because it took about 17 minutes. So let's say that the halfway point should be half the time. So 8 minutes. So I'm going to come over here and type in that my time is 8. What units are your time value? You should look at your time in seconds. Oh, so let's go check my graph. Well, mine's in minutes. There we go. Now it's in seconds. And the way we did this actually is that this, I'm going to delete this column. You don't have to calculate this by hand. A lot of my students will sit there and pull out a calculator and do minute times 60 every single time. We don't need to do that. We're actually going to insert a column. I'm going to name this time in seconds. Say this is variable S, seconds, variable is T. Change the column formula. I know that minutes to seconds is just minutes times 60. So I do time times 60, submit. Boom. There's all my time values in seconds. It saves so much time. And as an instructor, I can actually pre-program this for my students. So if you're working with students who are like, they're not going to get that. I'm working with freshman physical science. Honestly, if I'm probably not going to do this activity with freshman physical science, just as a big heads up. Like, I'm not going to cover first order rate laws and logarithmic functions with students who haven't completed algebra 2 or are concurrently enrolled in algebra 2. I'm not that brave, but there are people that do it. So I don't have to manually do any of that. It'll automatically calculate for my students. And then they can just choose. And now I can say like, oh, well, if this is 1040, the halfway point should be about 500. So 493. Let's come over here. 493. We're not looking when it levels off. We want it to reach the 50% of the starting point. Oh, so 50% up here. So I should be looking at a different halfway point. So 500. Hey, look, I've got one that's at 500. So 208.2. Each time I'm typing in a value, I'm getting a different feedback, and that one should have given me the correct answer. 220. Let's try that one because the other one looked like a pretty big outlier. How about 180? There. Huh. I'll have to go look at the answers for this one. And so this should have told me that it was the correct answer. So I can copy it to my library, and I'm actually going to go in and look at it right now. So one of the nice things is when we're programming these questions, we have the ability to set all of these feedbacks. So if I go into activity content, here's that numeric question in part 2. Here are all my correct answers. So the correct answer is 157, is between 130 and 157. So that student's answer should have been between 130 and 157. I want that to have actually been 180 because it should have matched that response up there. So I have 1, 2, 3, 4, 5 different pieces of feedback here. So each time my students are working this out, the way this reads is that if their response is within 130 and 180, it's going to be marked as correct. Another cool thing is you'll see this tolerance. If I want them to have an exact answer, I'm going to set the tolerance to be 0. So if I'm looking for them to say that gravity is 9.81, I want it to be 0. But if it's a calculated value, say for instance, their answer should be roughly 2. How close to 2 do you want them to be? Within 5%, that's your tolerance. So you can say, I want you to be within 5% of this answer. And that allows for rounding errors, that allows for measurement errors, any kind of compounding errors. The other cool thing that you can do is you may see this thing that says vary, this variable. We can actually set variables within inside of an activity and give them random answers. So this is a little bit more on the text side of things. So you need to know a slight bit of math language. If you know Math.js, which is a math programming language, you can actually program your answers here to calculate for random variables. So I could give my students a random variable and say, your sample had a mass of 4 grams of magnesium in the reaction. How much hydrogen gas would be evolved in your reaction? And then you can program your answers to be formulas, and every single random answer will calculate. It will automatically match the correct answer for your student. And that's one that is like a little bit higher on the to-do list. Like it takes a little bit more time and it's a little bit more involved. So because of that, we're actually making a training for that process inside of our new Pivot Interactives Academy. So the Pivot Interactives Academy is an online training portal specifically designed for Pivot Interactives users, and it houses all of our internal trainings. We have 2 on there right now. One of them is an onboarding, and one of them's coming out this afternoon. It's a starting tips and tricks for Pivot Interactives. but we're going to add ones on everything that we're talking about today in a lot more detail. So you'll be able to learn exactly how to code all of those answers so that every single student in the class has their own random number and the computer auto grades for them. Imagine having 150 different versions of your assessment and every assessment grades on its own. That's what we can do inside of Pivot. It's pretty hard to check something when every single person in the class has a different answer. So that's our numerical auto grade questions. And these are inside of Pivot. You can do this no matter where your students are. But a lot of us are coming back in person. And perhaps you have things like this. This is a Vernier temperature sensor. And currently we have Bluetooth capabilities. So check this out. I'm going to go over to one of my student accounts. And I'm going to pull this onto the screen. Okay, so I'm inside of a student demo, and I actually did a little activity inside my kitchen. I took some ice and I melted it, and I connected this temperature sensor to my computer, and I was able to get a temperature curve for the melting of ice. So just to show you how I did this, I'm going to do one right now, just using the temperature probe in my hand. I'm going to let it sit on the table so that it's not the temperature of me yet. And we're going to connect a Bluetooth sensor so we can take live sensor readings inside of Pivot Interactives. So to do this, I need to configure a Bluetooth device. And right now we work with the Vernier GoDirect sensors. Anything inside of the Vernier GoDirect line, you'll know if it's a GoDirect sensor because it will say GoDirect on it. And the code that's on the back starts with GDX. So GoDirect sensor. But I can connect a Bluetooth device, and there it is, it shows up. If you have a whole bunch of these inside your classroom, so maybe you've got 10 sets for 10 lab groups, on the back of each sensor is an ID. It's right above the barcode, and that matches the ID that's on Pivot. So when your students are doing this in class, they just need to look at this. Generally speaking, the last two of the code are fairly unique, so you're not going to have any repeats of them. So I just look at it. It says golf 4. Hey, look, golf 4. Okay, cool. So pair. It might take a second for it to connect, especially since I had this connected earlier. There we go. I had it connected earlier, so it didn't want to disconnect. And I can set up my sample rate. So I'm going to set up a sample rate of 2 samples per second, and I want it to do 30 samples. We'll let it run for 15 seconds. So now it's programmed, and it's automatically made my time and my temperature. So I'm going to run this and just collect the data. To do this, I click capture. I'm going to put it in my hand. I'm going to heat this thing up. We've got friction. Oh, it's rolling out of my hand. And as you can see, all of that data is automatically appearing inside the data table. Normally, I would need graphical analysis for this. And then I would go from graphical analysis into Google Sheets, from Google Sheets into Google Docs, from Google Docs into Google Classroom. Somewhere along the way, a kid's going to lose something because that's how teenagers work. And then I've got to go find which program went bad in the little process. All of this is inside of Pivot. Their instructions are right there. Their data table is right there. Their graph is right there. I could graph this afterwards. I could configure the time and the temperature. Hey, look, there's my graph. Or I could do it while it's live. So I'm going to reset this data table, blank it out, and I'm going to reconfigure this device. And I'm going to go ahead and set up my data table and graph. So before I actually do any data collection, my data table and graph is already set up, ready to go. I'm going to do the same thing. I'm going to capture it. And now, as it sits in my hand, you'll see that this is, whoops, graphing right underneath it. There we go. So it's live graphing. I didn't need any extra programs. Everything's right there in Pivot. And what I love about this is I'm going to grade it inside the platform. My students are going to do their lab. I'm going to have all my questions right here. I can even see this in real time. This is a student account, right? I'm going to come over here, and inside my teacher account, I'm going to go to my classes. And that's the temperature sensor demo that my students have. There's my fake student. I see that they're working. I can see all of their work right now. So in the past, I couldn't see their graphical analysis unless I got up, walked over to their computer and looked at it. Or if I'm in Zoom, I got on a Zoom call, they shared their screen, and we all know how much fun it is to explain to students how to share your screen. It just doesn't happen. By the time you walk across the classroom, usually something's gone wrong. But I can load the students' answers right now. I could even send this information to my students. So I'm going to come up to my students' activity, and I'm going to go over to back to the scores view. And I'm going to preview the activity. So here's what the activity looks like to start. Maybe I want them to have a graph. I'm going to demo it for them. And I want them to use our in-class demo data to answer a bunch of questions. We can do that. All I need to do is edit the activity. And then I can actually come over to that data table and graph component. And there are two features here. One says correct answer. One says pre-populated value. I can connect to the pre-populated. And this is probably going to give me, oh, nope, it connected with no problems. Look at that. I'm going to just give them the data. Just hit capture, rub this thing in my hand. This is going to capture the data for the whole class so that when I'm done, what the students see when they open it up is our completed data. And so this thing is over here. Get nice and warm. We're at 30.6-ish. Look at that. Awesome. I hit save, and now all my students have that data. Huh. So this is what they would see when they come into the activity. They would see that they have this data table completed, and that now they need to set up their graph. So I can give them a sample and say, it says graph temperature versus time. They've already got all their data. Well, that means I need to put time here and temperature here. Cool. And now I could ask them follow-up questions based on the demo that we did in class. So I can do it up at the front. We could do it in a small group because sometimes you've only got one of the probes. You don't have to be limited. All of your students get it. There's no copying down data. And even your students who are absent that day are going to have this. That was one of my biggest hurdles as a teacher, was keeping track of all the kids who weren't there and getting the lab data to the kids who weren't there. Or by gosh, I had one year where I was like, I'm going to do makeup labs. You do one makeup titration in your lifetime where you have to set up all the burettes and get everything in there. You do it once, and then you realize that you never want to do a makeup lab again a day in your life. And you're like, no, you're going to copy the data from somebody. And the students are like, well, I can't find anybody to get the data from, or my data was bad, or no, I can give everybody the data at the exact same time. And I have a log that I gave it to the students because that's what everybody's activity looks like. I didn't even have to go to a photocopier. It's done. And I've saved this for next year too. It's always there. Another fun thing is too, if I go, I'm going to head over to that student account really quick. Boop. If the student resets their data table, That's the blank one, but here's the one. I'm going to refresh the page. If the student resets their data table, it resets them to my data. So a lot of times, if you've ever worked with students who are like, oh, I know how I won't do the question, I'll just delete it. I'll reset the data table and say, oh, Ms. Detweiler, I didn't get the data. It just didn't work for me. No, sweetie. If you reset the data table, it puts you back to my pre-populated data. So they always have my data. It is the blank value. So I think like this feature here is so great for us as chemistry teachers. We have obviously temperature sensors, pH probes, CO2, O2 sensors, anything that you've got in the Vernier line, go for it. And we have sensor labs that are starting to appear inside the library. So if you come over to our library, I'm going to look for sensor. Helps if I spell the word sensor right. There we go. We're in the process of adding more sensor labs, but this is one that we just did for chemistry. And it also uses a temperature probe, but it's looking at intermolecular forces and evaporation rates. And so we have 3 different modes that the students interact with in this activity. They're going to do a hands-on demonstration where they dip a paper towel into ethanol and water and then smear it across the table. And we do tell you, make sure you wash your hands, don't ingest any. And then inside the teacher notes, we include some additional information that ideally you want to use 95% ethanol. 95% ethanol has the better evaporation rate. The 70%, it's acts more like water. But we tell you this is what you should see. The students are going to dip their paper towels in, rub them across the table and see that the ethanol evaporates really quickly and the water doesn't. And then they're going to dip their fingers in and feel that the ethanol feels colder. And that was the spread the layer. And then we're going to actually have them do evaporation tests with temperature probes. And we include all of your instructions on how to do that. So we're going to tell them the power button is that thing right there. Like there's a button on this, just in case your students don't know. And we show them how to connect all their sensors. And then we give you, the instructor, additional information here. All this stuff that's in gray, your students don't see that. So this one says when collecting 2 samples per second and 120 samples, the students will collect 1 minute of data. So we're giving you additional background information that the students don't really need. And for our correct answer, we have our own sample data that you can see. So this is the water trial. Yep, that's the water trial. And then underneath it, we have the ethanol trial. What I also love too, something that we don't point out in this activity, if you have multiple sensors, you can actually connect multiple sensors to the same data table to do multiple trials. Right now, you can't do multiple trials on one sensor. You would need to do multiple sensors. So the way I've done that is just have your groups rotate sensors, and then they disconnect the old one and then reconnect the new one, and it will just make the next column next to it. So you could have trial 1, trial 2, trial 3, but you will need 3 different sensors, 1 for each trial. If you run it, it won't delete your old data. It'll just capture in the next column. But if you use the same sensor, it'll write over it. We're working on setting this up so that one sensor can do multiple trials. But for right now, if you want to do multiple trials, you need multiple sensors. But I love that in this activity, so they're going to do that multimodal. So at the beginning, we're going to demo it. We're going to observe it. Then we're going to use this temperature sensor. And then we follow it up where we observe intermolecular forces through the video. So they're doing 3 different learning activities, all with intermolecular forces. So I'm combining hands-on, like actually experience it, with let's do a lab, with let's follow this up with a video that you couldn't make inside your classroom. because these videos, this is a really high definition video. And we're looking at the stretch distance of ethanol. I'm going to pull out my ruler and we see how far ethanol stretches. Should pop any second now. There it goes. So I can measure that stretch distance for ethanol. And then I can switch to water and measure that stretch distance. And I also love, like, this is such a minor thing. See that little bit of water that's still clinging to the side, the micrometer? Ethanol doesn't have that. It's already evaporated. So a lot of times I'll ask my students, like, why is that there? All the other ones have been clean shots. What's with this? It might have something to do with the fact that the water is just going right past. It got to what, 3.9 millimeters? Let's see. Yep. 3.9 millimeters.
I like the little cartoon character in there too.
Oh, Marie Curie. Yeah.
Oh,
We have a Marie Curie bobblehead in the background and she has tiny little gloves. But
no, I logged in a little bit late, and I went to the site for Pivot Interactives. I was wondering how does the just to get started, just to check it out, I didn't actually sign up for the free trial. How long does it last?
It lasts for 30 days, but I want you to be able to use it with your students. So if you go ahead and sign up for a free trial and then email me, and I'll put my email in the chat, I'll be glad to extend your trial so that you have 30 days of access with your students.
Okay. All right. Very good. Because it'd be good to just, look through it a little bit before I start to see what I can use. I have different levels, I have my, different levels of chemistry. I think how have you used it mostly just for your honors, like an honors or a?
No, I actually taught, most of my classes were standard chemistry. So I used mine with students who were concurrently enrolled in Algebra 1. So fairly low level. One thing that I will say is when you're inside the Pivot Interactives library, come over here where it says level of scaffolding and look at high.
Okay.
And we have all of your introductory activities right there for you. We've also started coming out with some that are like really a lot lower level. So you can also look for grade level and we'll tell you which ones are better for advanced high school, which are better for more standard. And we have some that are for middle school. So I used to teach a physical science class for freshmen and students that were struggling with reading and mathematics. I used a lot of middle school content with them. We have middle school activities.
Okay. Very good.
And so I can look here and I can see, like, here's a limiting reactants activity. We're going to introduce limiting reactants without getting into the math. And so those are super great for a lot of our intro students. Another awesome thing, and this is like my last awesome thing, you can upload your own videos. So you can actually make your own pivots from scratch. So I've got a physics example and I was working on a chemistry example, but my video was too long, which makes me super sad. But so I have this physics example of a pendulum one, and it's a student instance upload activity. And what the students see is this. The students are going to make their own video. So this one tells them in the space below, upload a video of a simple pendulum in motion. And so I made a simple pendulum video. Here it is. They just click update. It uploads the video. Now they gain access to our tools. I can use our stopwatch, our protractor. And this is going to move angles. I'm going to back this thing up to the beginning. And let's move the protractor out of the way. All right. I'm going to let go. Back. All right. That's the moment I let go of the necklace. Reset the stopwatch. Let's see how long the period is. That's the point it starts to turn back down. So 1.4 seconds. Well, for a pendulum, that period should be the same throughout. So let's see. Oh, 1.4 seconds. I made that at home, and hopefully you don't hear my dog squeaking too much behind me. She has her little squeaky toys. They have been hidden all over the house. I have a Pomeranian. She is very enthralled with her squeaky toys. This isn't any kind of special filming equipment. This was my phone. That's a necklace that I had. That is a hook that had a picture on it that I pulled the picture off to hang the necklace on to let it swing back and forth. There is nothing fancy about this video. My students can upload their videos straight into Pivot. I can upload videos straight into Pivot. I can make my own activities from scratch. So if you have an activity that you're like, wow, it would be super cool if I could film this and show this to my kids. Okay, do that. We have that ability. And then they get to answer all their questions right inside the platform. So in this one, I asked them, tell me what quantities are you going to measure? Give me your procedure. Here's a data table and graph. Determine acceleration due to gravity. All of that happened right inside of Pivot. Now, the one I was filming this morning for chemistry was I was looking at reaction rates, and I want to get really precise time data. I can do that because I can now move frame by frame. You can get your time super, super precise inside of Pivot. So the one that I was filming out there was steel wool, just different surface areas of steel wool, stretching it out and looking at, they burn for the same amount of time, but the more compact steel wool will have a lower reaction. It won't be as reacted as the one that was super spread out. The other one that you can do at home is Alka-Seltzer tablets in different temperatures of water, and just going from hot water versus cold water and percent mixtures thereof. You can get your varying temperatures, and they don't need a thermometer for it. They can just do the qualitative hot versus cold and then reaction time, and they get really great data. But they can film all of those and do their time measurements inside of Pivot. So they get super precise time measurements right inside the platform. So, and just to show you what other teachers have made, if you come over to the community library, we have 435 activities in our library. The community library has over 8,000.
Wow.
And this is one somebody made. It's thin layer chromatography. This instructor made their TLC lab and put all of it inside of here and filmed the whole thing. So they have all their pictures. This thing takes forever to load. But they filmed every single part of the TLC process and uploaded them as videos, so that their students could see from start to finish the entire TLC process. Super easy to do. And you get to save them for years and years and years. Like, this isn't going anywhere. It's yours. We never delete your activities. We never delete your profile. It's yours for as long as you want it. And I should mention the cost. All of this is $5 per kid per year. So for a class of 30 kids, it's going to cost you $150 to have access to all of this for the entire year. And there are discounts if you're teaching, if you get like bulk purchases. So generally speaking, what we see is that one of the teachers gets one of the other teachers, gets one of the other teachers, and before you know it, the whole department's like, yes, we want this. When you start getting into school level purchases, that price starts to plummet. So I've seen people get them for less than $4.50 a seat. And if your school is interested in a trial, we will gladly make you a trial license for your school so that everybody at your school can try it out at one time. And then at the end of the license, you could just purchase what you've used. So if at the end of the license, everybody uses it, cool, purchase for everybody. If half the teachers didn't, don't purchase for them. We're very flexible in how we provide this for teachers. And we also have an integration with Canvas, D2L, and Blackboard. So any grading that you do here is going to automatically go to those grade books.
I didn't hear Schoology in there.
We don't have a Schoology integration yet. Schoology has been saying that they are going to be LTI 1.3 since the end of 2018. So we're waiting for them to actually finish the thing that they said they're doing, because it comes down to it's a grades issue. On anything that's older than LTI 1.3, there's a security flaw in sending grades into it. And so there's a vulnerability. We're not going to let your student data be vulnerable at any point in time. So as soon as they will update to the industry standard, we're compatible. We're just waiting for them to beat the industry standard.
Wow.
So yeah, we're hoping to see them here soon. Google Classroom is also in the same boat, and Google Classroom is supposed to be getting to 1.3. Maybe we'll see. It's Google.
We have something called it's called Power School or Power Teacher.
Yes. So Power Schools is a grade book. You can actually download a CSV file from Pivot and upload it straight into your grade book. So that's generally speaking, when people use, I use Google Classroom, but it was not my grade book. We used Infinite Campus. I could download a CSV and upload it, and it takes a couple of seconds. Are there any questions I can answer? I know I've thrown a whole bunch of stuff at you guys today.
Well, I'm definitely going to go in and start a trial.
Absolutely.
Send you an email. This is something that could be so useful. So thank you.
Yeah, and we're constantly adding to our collection. So if as you're looking through, you're like, man, it'd be really great if you had insert topic here, let us know. We love to add those things, and we're constantly finding new activities to put in and coming up with new ideas. Every time I sit on a content meeting, somebody's like, I saw this thing and I want to do it now. That's how we got the glow stick one. Was somebody was like, it'd be really cool if we played around with glow sticks and temperature. I was like, yeah, it would be. You should go do that right now. And they were like, okay. And then 2 weeks later, poof, glow stick activity appeared. And I'm going to get you guys the link for the trial. And the nice thing is too, when you sign up for a trial, it's going to take you straight in. You'll immediately have access for a trial. The only thing you won't have access to is the answer keys. We manually vet everybody who requests a trial so that our answer keys don't end up in the hands of students. So it usually takes a few hours, and we've got you in no problem. But thank you, ladies, so much for coming. If there's any questions I can answer, by all means, I'd love to answer them. If not, I hope you enjoy the rest of your conference.
Thanks, Linda.
Thank you.
Thanks, Linda.
Thank you.
Thank you, Linda.